So, welcome to the third day of NORMA. I will start with a very short practical information. That is that the strike is now cancelled in Norway. So one of the presenters that was cancelled yesterday is presenting on Friday instead of Edith Ryder Moswell. So now it is my pleasure to present the plenary speakers today, Cecilie Bach og Uffe Jankvist. In her recent PhD dissertation, Cecilie focused on students' development of communication competencies when they used geometry in lower secondary education. Cecilie was awarded for her dissertation by the Research Foundation of University of Aarhus. Cecilie is the author of several books to lower secondary teachers about students' difficulties with mathematics. Now she has a postdoc position at the University of Copenhagen under the auspice of the new Center for Digital Technological Understanding. And Uffe is a professor here at Aarhus University. He is also the professor too of the University of Uppsala in Sweden. He is an experienced researcher with many research publications, and he has a high success rate in obtaining financial support for research projects. That's very important, as you know. He is also the supervisor of many PhD students, maybe the most PhD students in Denmark. And he is the author of several books to upper secondary teachers. And then he is a chief editor for a relatively new international journal called the Implementation and Replication Studies in Mathematics Education. His research focus are the use of the history of mathematics in mathematics education, the use of digital technologies, and the Competencies framework. So a warm welcome to both of you. We are looking forward to hearing about your joint project.
Thank you. Okay, so thank you very much for the invitation. The title of the talk is Math Mastery in the Digital Age, the Confluence of Digital Tools and Mathematical Competencies. ChatGPT invented this title for us. That's why it sounds so cool, right? So this is the way we're going to do it. I'm going to say some introductory stuff, show a lot of pictures. And then Cecilie is going to do the deep analysis of what we did in the project. And then I'm going to show some more pictures. Okay? So, the talk is about a research project that we obtained some years ago that takes its departure in the Danish COMP framework that came out in 2002. It was published in English in 2011. And Thomas and Morten had a paper in educational studies in 2019. They're currently working on a book with Springer also, discussing the influences that the COMP project had on various research and curricula across the world. In Denmark, this idea of mathematical competencies entered into the school system at both primary, secondary, and upper secondary levels, also teacher education to some extent, and has sort of permeated, at least for some time. The winds may be changing, of course, but has done so for a couple of decades. And it also has influenced other countries, Norway, Sweden, even Colombia, I think. Måns talks about that quite often anyway. For a little while, it was also in the PISA framework when it was run by Acer in Australia. Now it's run in the US and they do it differently. So many of you probably know something about the competency framework, so we're not going to explain this in a lot of detail, but a mathematical competency is defined as well-informed readiness to act appropriately in situations involving a certain type of mathematical challenge. The framework consists of a description of 8 mathematical competencies that you see there in the flower. The idea is that even though they are distinct, they're also overlapping. You cannot possess one in isolation from the others. It also has 3 types of overview and judgment, or so-called second-order competencies. These concern the nature of mathematics as a discipline, the role of mathematics in applications in the outside world, extra-mathematical world, and the historical development of mathematics as a discipline. And then it has 6 didactical pedagogical competencies for teaching that we often do not hear too much about, but they are there, and they are useful. So we'll get back to that. Something else that has happened in Denmark, and other countries as well, but I think in particular Denmark, is the introduction of digital tools into the school system. And where other countries, such as Germany, for instance, have been a bit more reluctant to include it into assessments, etc., Denmark went all in right away. And this, how would you phrase that politely? There are, of course, very positive things about the use of digital technologies, but there is also a couple of downsides about it. But from a research point of view, it's wonderful, because you can do a lot of research on what happens when you go all in without really thinking about the consequences at first. So Morten and I have done a lot about that. And now also the doctoral students, but they have done it, of course, in a more reflective way. So we have at primary and secondary mathematics programs, we have in particular dynamic geometry environments, such as GeoGebra. And at upper secondary mathematics programs, we have CAS, computer algebra systems. So if some of you were at Mathilde's talk yesterday, you saw how this plays out. And it's part of the national written assessment, right? And that's the important thing. So of course, the comp framework does have this competency on aids and tools, right? But that's not only digital tools, it's all kind of tools for mathematics, ruler, compass, abacus, you name it. But of course, they also mention just a little bit about digital tools. They say that the competency consists, on the one hand, of having knowledge of the existence and properties of diverse forms of relevant tools used in mathematics, and having insight into their possibilities and limitations in different sorts of contexts. And on the other hand, being able to reflectively use such aids. So the important thing here for us, which is actually also found in some of the theoretical frameworks that Cecilie is going to address shortly, is this thing about possibilities and limitations. It's also part of the instrumental approach to using digital tools in mathematics. But the competency is also very tightly linked to some of the other competencies, in particular the representation competency and the symbol and formalism competency. So we're going to look at that too a little later also. So the rationale for this project concerned the discussions of mathematical competencies and the use of digital technologies in mathematics education, and the fact that these two discussions somehow seem to have run on separate tracks, and not only in research, but also to some extent in practice. A key feature of the project proposal was to look at a potential interplay between the competencies and the influence of these digital tools. And we had an idea that we could do this applying design-based research, but also this approach of networking of theories in mathematics education that came out some time ago. In particular, it was born in the ERMI group and has been developed since. And maybe you know this figure on strategies for networking of theories, and we were sort of initially aiming for something that could be defined as coordinating or combining, maybe even integrating locally if we were lucky. But this, Cecilie is going to talk more about. So The initial research questions of the project, back in the day, 2018, was in what ways may the mathematical competencies approach be networked with existing theoretical constructs, results, and findings from the field of mathematics education research in relation to the use of ICT, we called it then, in the teaching and learning of mathematics, and in what ways may a networked frame consisting of the mathematics competencies approach and selected well-established theoretical constructs for math education research inform and improve the use of digital tools in current and future mathematics teaching and learning. At that time, the project also had a very fancy title, something with 21st century, blah, 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 but this was mainly in order to get funding. So this is a slide on the project organization. So we were granted the project in 2018. We began in 2019. It was prolonged a bit because of COVID and other things, and it's going to end at the end of this month, actually. It employed 2 doctoral students full-time in the project, 1 postdoc for a shorter period, and 2 other doctoral students. Cecilie being one of them was associated with the project, but they had their own funding. There was a team of 4 international collaborators, and there was an international advisory board. And as you can see in the figure here, the competencies that we mainly addressed were the mathematical thinking competency, the reasoning competency, and the communication competency. But in doing so, we found out that we could not really address these without also looking into, of course, aids and tools, since it was on digital technologies, but also representation turned out to be essential for a lot of the things we did, because these other competencies overlap with the representation competency. This was our advisory board that we actually managed to make quite well good use of. They were here on several occasions, presenting their own work to the doctoral students, discussing the thesis of the doctoral students with us, etc. You know them, of course, I'm sure, Susan Prediger, Hans Geo, Måns Nis, and Maria Alessandra Mariotti. This was the group of international collaborators. So it's a pre-corona picture. There were less facial hair at that time. So, but Morten Misfeldt and Mario from Mexico City, Anna Bacalini Frank, and Irene Geranio from London. And then the main actors of the entire setup were these doctoral students. So Ingi had a funding from the PhD Council, which is a Danish funding body for PhDs in relation to primary and secondary school. And he looked at reasoning and digital dynamic geometry environments. He's now back at the Faroe Islands. He has a position at the university there. Cecilie was a PhD. She also had her own funding from Aarhus University and continued into a postdoc funded by this project. And Cecilie looked at communication competency. Mathilde looked at the thinking competency. She was employed in the project. She handed in her dissertation this spring and will defend on Monday the 17th this month. And Rege looked at reasoning competency, and she will hand in hopefully this month. So, and if you look at if you wonder about the duration of these PhD positions, it's because this project not only gave birth to dissertations, but also 5 babies, right? So a lot of maternity leaves here. Very productive. Yes. And I think that's it for me. Now I give the word to Cecilie. No, I have more. Okay, I wait with that. I say some more. So yes, this is true. I talk about we did a book as part of the project. And this was the way that we structured it, actually according to the comp framework. So a preface, of course, and then some introductory parts, a chapter for each of the competencies, a chapter for each of the 3 types of overview and judgment, and then some more perspective chapters involving addressing also these 6 didactical pedagogical competencies. And one of the things we wanted to do with this book in particular was to have, to the extent possible, the doctoral students author chapters with more established researchers. So you see, for instance, Rikke wrote a chapter with Anna Baggalini-Frank, who was also her co-supervisor. Ingi wrote a chapter with Maria Alessandra Mariotti, whom he visited as part of his PhD. Cecilie visited Angelika Bickner-Aschbahn and wrote a chapter with her and some other papers as well. And then there were a lot of doctoral students, as Charlotte said, in and around the project somehow. For instance, Maria Østergaard contributed with a chapter. Also, Marianne Thomsen contributed with a chapter. Mario did a chapter with some of his students. Yeah. I'm just going to do just a couple of downstrokes to illustrate to you what were some of the contents of these chapters. So, in one of the first chapters, we thought it was wise, and it turned out to be right, to have Mogens actually look at, together with us, how to potentially use other theoretical constructs in combination with the comp framework. That way we were also kind of sure that we wouldn't do anything wrong, right? So, so that was the main purpose of this chapter. But it was also a chapter that turned out to be quite useful for the doctoral students because they could refer to this when writing their CAPAs in their dissertations on how they actually worked around the problems they were looking at with the competencies, the digital tools, and what other theoretical constructs they were applying to do deeper analysis into mathematical understanding, knowledge, etc., use of digital tools. So some years back, Mogens and I designed this math counselor program for upper secondary school teachers, and Morten Blomhøj has also been involved with this. And at that time, even though we used the comp project, we also experienced that the teachers, when doing analysis of what the high school students were doing, they needed more than just the comp framework. They needed other theoretical approaches. So we were inspired by this, our experiences there in writing this chapter. And then a chapter written by our Swedish colleagues, Linda Ahl and Ola Helenius, on the symbols and formalism competency, where they illustrate how Vergniaud's theory of conceptual fields can go actually quite well hand in hand with the competency approach. And actually it also turned out that a lot of the doctoral students also outside the project, they came to be very fond of the theory of conceptual fields and using Vergniaud. We even gave a PhD course, or we had Linda and Ola give a PhD course on this for the doctoral students. That was one part of the course, and another part was Luc Trouche explaining to us about the instrumental approach. Because as it turns out, this notion of schemes from Vergniaud, that of course goes back to Piaget, works quite well with a duality called the scheme-technique duality in the instrumental approach. And now it's true, I actually do give the word to Cecilie.
Right. So, I'm just going to grab this one. I'll be presenting first the work from my PhD, which concerns students' mathematical communication competency in settings involving a dynamic geometry environment. And as Uffe described, the project is within the intersection of the use of digital tools and mathematical competencies, and then, of course, mathematical communication as a focus on mathematical communication competency. Just to begin with, what is the mathematical communication competency? It concerns students' abilities to express oneself mathematically and to understand and interpret others' mathematical expressions. And it involves different kind of media, genres and discourses, and also communication to different people, so both peers but also teachers. And then of course it needs to be communication of mathematical nature, meaning communication that involves notions and concepts and terms, results, or theories, or other features of mathematics. So when I first started this project, I wanted to go into lower secondary school, and we wanted to use GeoGebra as it was very widespread within the Danish school system. And I developed a task inspired by Johnson and McClintock's task on functions as covariation, and we used some templates which the students should use when they focused on a linear relationship, or that was the first part of the task. And the students were able or should investigate the relationship between the rectangle and point P. And point P's x-coordinate is equal to the height of AB in the rectangle, and the y-coordinate is the area of the rectangle. And then it's a linear relationship y equals 3x. So when I went into the classroom for the first time, I was very excited to see students communicating, and I wanted to use this competency framework. So this is a short example of a communication situation involving the dynamic geometry environment. And one student says, yes, so if we change, and the other girl responds, so P moves askew to the right, and the other one responds, and the rectangle's area, okay, then we change. And then the other girl responds again, well, if it moves askew to the right more and more. And this is a situation which is quite common. And I wanted, of course, to use the mathematical communication competency description, but it was quite difficult. So this led to this investigation of finding relevant theoretical perspectives to understand the situation of students' mathematical communication when using dynamic geometry environments. So I wanted to explore and design teaching and learning situations involving a dynamic geometry environment that potentially allows students' mathematical communication competency to be exercised, but also to characterize situations in which the students may not exercise such competency. And then, of course, I wanted to understand the relationship between students' mathematical communication competency and their processes of instrumental genesis. I did a design research study where in 3 iterations and 1 pilot study where I began to first explore the relationship. I went into a classroom, I saw what happened when we went in there. Then we had some deeper investigation and some elaboration. And I did a bunch of different kind of work. And today I want to focus on a paper or the book chapter from the book Uffe just showed us before, which I did in collaboration with Angelica Bigner-Aspas. As this actually shows the development from each iteration, but also how networking of theories were fruitful as a means to relate different theoretical perspectives to understand the situation better. So, as I just saw you, we needed to relate these 3 areas. And first, I'm going to describe these theoretical perspectives later, but in the first iteration, we just wanted to explore which theoretical perspectives were relevant to use. And we found that a notion called impractical talk, which was not then very settled within the literature, but it was related to students' use of CAS when they communicated, and that the communication were very centered about this use of CAS. And then we used some profiles characterized by Gwyn and Trusch in the instrumental approach, and we could see that the more difficulties the student experienced with the use of dynamic geometry, the more impractical they talked. So, within the second iteration, we wanted to investigate this relationship between the theoretical perspectives even further, and we wanted then to conceptualize the concept or the notion of tool-based mathematical communication. And we wanted to network 2 theoretical perspectives. We found that in practical talk is from a previously or psycholinguistics, where they distinguish between 2 kinds of verbal communication, and then instrumental genesis. And the reasons for using these theoretical perspectives is that COM is of cognitive nature, and we wanted to develop a notion or a theoretical understanding which is compatible with this cognitive perspective. And we found that both these theoretical perspectives were quite relevant in this regard. So, just if you're not familiar with the notion of, or the practice of networking of theories aims to understand and relate unrelated theoretical perspectives from mathematics education. And it's applied when we have more than one approach, and when we have the aim of establishing links between these theoretical perspectives in play, and that is both theoretical and methodologically. And then we have these 8 strategies, and within the paper with Angelica, we started by focusing on coordinating, as this concerns theoretical understanding related to an empirical phenomena. And when it's conducted deeply, then it can lead to integrating locally, which was the case for our book chapter. So, the 2 ways of communicating mathematically that we applied was the mathematical conversation, which concerns conversations in, with, and about mathematics. It requires speaking and listening, and here listening is active, whereas hearing is passive. So when you listen, you're an active participant within the communication. We have an equal participation and turn-taking, and a wish to bring the conversation forward. On the other hand, we have impractical mathematical communication, which is rather non-linguistic. There's a focus on practical activities, such as using a digital tool. And we have a lot of breaks, and it may be less coherent. And the reason why we like this to distinguish is that we have we thought that when they used or had a mathematical conversation, they were likely to exercise or even develop mathematical communication competency at the same time, because they would focus on mathematical communication, whereas in the impractical mathematical communication, they were rather focused on the use of the tool, and thus they would not exercise mathematical communication competency. So if we return to the short example here, we found that both students are speaking, but it does not appear that they are listening to one another, because they are so immersed in doing and using and understanding what is happening within GeoGebra. Then we applied the instrumental approach, and here we can distinguish between the notions of artifact and instrument. An artifact is a physical thing, and when we get to use it for a given task, it becomes an instrument. So for instance, a pen, when it can be considered an artifact, and when we are capable of using it to write with, it's an instrument for that particular purpose. And then we have the processes of instrumentation and instrumentalization. And this is a dialectic relationship. Broadly speaking, we may say that instrumentalization is how the student shapes or uses the tool, and instrumentation is how the tool relates or affects the student. So that is very closely related to conceptualization. Then we have these 5 profiles for the use of computer algebra systems defined by Gwyn and Trusch. I'm not going to characterize them all, but it's if we look at the random profile, this is characteristic for students experience difficulties, both with and without the digital tool. If we have the mechanical profile, this is also characteristic for students with experiencing many difficulties, but it's quite restricted for the use of computer algebra systems. And then we have a theoretical profile where the students are not experiencing difficulties, they are quite proficient, they understand the concepts in play, and they are capable of both having different resources to solve a task, both with and without a tool. So, if we return to our example, this is of course a short example from a longer excerpt, but we see that the students are experiencing difficulties. They have many references to the dynamic geometry environment, and they are very keen of using this tool. So we may say that they have a mechanical profile for the use of this dynamic geometry environment. So if we just move into the result of these tool-based mathematical communication, it may be described as a particular type of communication linking cognitive linguistic resources with cognitive action schemes developed during instrumentation, which emerge in connection with communicating and acting. And we found that these profiles were very related to the particular situation and may be a particular new situation of the relation, how the students communicated later on in the class. So if they showed impractical communication in one situation, they may show a conversation in the other. And we found that the use of the tool were very related to the communication. And then we could distinguish 4 types of tool-based mathematical communication. Within the paper, we described 3 kinds empirically, and we found 4 kinds theoretically. So we could distinguish between mathematical conversation and impractical mathematical communication. And then we could see that the students communicated differently. So in some kinds of the communication, or in some times of the tool use, they actually tried to idle the tool. That was shown for some students showing a random profile. It could be because the situation was so complex that they tried to reduce it, trying to use it as a still picture. And then the other kinds, it was so the tool was very embedded within their dialogue, and they were really exploiting these dynamic representations within the tool. So for instance, we found that students showed a tool-embedded impractical mathematical communication when they had a mechanical profile, experienced difficulties, and relying on the tool. Okay, so within the 3rd iteration, we wanted to find this 4th profile, which we couldn't see, as it was a tool idling mathematical conversation, because the students were also here likely to exercise a communication competency. So we actually revised the task. We even tried to change the properties of the rectangle, providing the students just with a picture of the tool instead of having them to drag. But they actually kept on returning to the template, and we couldn't find any signs that they did idle the tool, even though we actually did it on purpose. It also showed us that which I have had many discussions with Angelica about, that in the beginning and within the first iterations, we tried to see what emerged from our data, whereas in the final iteration, we went in and looked very deeply just for one particular thing, and in that regard, we did not succeed. So, to sum up on the results from my PhD project, this is just some brief ones. Exercising mathematical communication competency when using a dynamic geometry environment is indeed challenging. When using a dynamic geometry environment, students are provided with many new ways of communicating. And when this use of the dynamic geometry environment may lead to a very strict focus on the use of the tool, rather than on communicating, because they are trying to understand how the tool is used. And this dynamic linking between the representations in the tool are both providing potentials for investigating and conversations, but it also provides constraints related to communicating and the process of instrumental genesis. All right. In the following part of the presentation, I would like to focus on the mathematical representation competency and digital tools, as this is some work that we did in our group of PhD students as part of Uffe's project. So instead of focusing on having a free research areas, whereas the first one is on mathematical communication, we are focusing now on mathematical representations. And I would like to show you a work where we began by looking in literature and finding some humble design heuristics, design principles for the designing teaching situations in which students may exercise representation competency when we use digital tools, and how we in a networking process try to refine these design principles. Yes. So, the representation competency concerns students' abilities to interpret, translate and move between different representations, choose and make use of different representations, and understand scope and limitations of different representations. Within our literature, we, based on 30 studies, we grouped them based on the representation competency, but also developed semiotic register approach to find out these 5 recommendations for teaching and learning. And I'm going to focus on 3 of them, and actually only 1 due to time limitations. But because we focused on refining 3 of them as they were relevant for the task that I had developed. So the first one was including linguistic discursive registers, both at the beginning and at the end of each task, and that the different objects and representations within the tool should be broken down into smaller units. And then finally that the use of sliders and tracing and dragging should be included within the task, because they hold potentials for students' abilities to translate and move between different representations, as well as interpreting and understanding different representations. So our aim in this paper was both to investigate how these practices from networking of theories were related to design research, and then of course adjusting these recommendations into design principles using an empirical case. And yet again, we did the same task of finding relevant theoretical perspectives related to as COM is again of cognitive nature, and we had the instrumental approach, and then we wanted to develop semiotic register approach, as this is also a cognitive perspective. In Duval, he distinguished between 4 kinds of registers: the linguistic, the symbolic, the graphical, and the figurative. And this is, of course, a very short introduction, but he can within Duval distinguish between 2 kinds of transformation. The first one is a treatment, where you make transformation to a representation within one register. So for instance, if you want to reduce an algebraic expression, and then you can do a transformation across registers. So that is if you want to convert, that's a conversion where you make a transformation from for instance, an equation to a graphical representation. And then of course we have the instrumental approach, distinguishing again between artifact and instrument, and instrumentation and instrumentalization. And we wanted to do a coordination strategy, or use this strategy, as it aims to understand this empirical phenomenon of students using a dynamic geometry environment and exercising representation competency. It provided us with the possibility to use triangulation to understand it. We wanted compatible theoretical perspectives, and then we did the work in using parallel analysis. This is a case from our paper, and it's a very short one, where the students say, the area moves P, okay, the area moves P up. The other girl responds, no, it's not the area, you mean the width. Ivy says then, yes, but the width changes the area. So does the height, says Aya. Yes, yes, says Ivy. Aya then responds, but both factors move the area. Ivy then says, no, but no, try to see if you move this one up here, it changes both the area and the height, then it moves askew. And then Ivy actually drags point D, which is an unintended use of the template, because it had an error in the construction. So she could move P in this direction instead of just A up and down. And I just want to show you an example of the coordinated analysis, because they actually try to use dragging as an instrument, and they develop these schemes in which they relate treatments within the individual representations, so they relate the treatments of the rectangle and for point P, and then they make and try to understand the conversions between the point P and the rectangle. We used this to refine design principle number 3, and that was on the use of sliders, tracing and dragging for explorations of different representations and their representation forms reciprocal relations. And we refined this using our coordinated analysis to be using sliders, dragging and tracing for explorations about different representations and about the treatments and conversion caused by dynamic features, since these features makes it possible to quickly move and translate between different representations, and for developing conjectures about representations' reciprocal relations. All right, so to sum up on our work on the representation competency, the processes of instrumental genesis and the student's representations and the transformations of these are closely related. The theory of semiotic registers and the instrumental approach are compatible. They are both cognitive and applicable when we use a situation concerning the Danish competency framework. And then we developed this overall design principles using van der Akker, stating that if you want to design teaching and learning situations involving a digital tool for exercising and developing representation competency in schools, you are best advised to slowly relate all 4 registers in a task sequence. And then collaboration between students is essential for all 3 characteristics and procedures. All right, so now to the last part of my presentation, where I'm going to talk about networking of theories and its relation to design research. What has been very key in my project is this attempt to relate unrelated theoretical perspectives to understand the situation of students' mathematical competencies and the use of digital tools in lower secondary school. And we did a bunch of work on networking of theories, but it resulted in a more maybe in some sense more complex situation in regard to my design research process, as I constantly had the focus on reflectively choosing theoretical perspectives, testing theoretical perspectives and their relations, and then reflecting on the theoretical purposes, theoretical perspectives, backgrounds, and their linking. It also got me to focus very much on this developing theoretical perspectives as part of my design research process, so not only focusing on, so I would both focus on practice and theory. What was common for our networking cases was that we needed an additional theoretical perspective which related, perspectives relating communication or representation and the use of digital tools. It always also concerned an empirical case, and we used compatible theoretical perspectives related to the Danish competency framework, and we used COM as what we could define as a framing theory, as it was our background theory within mathematics education that was the ground that helped us to choose and pick these different theoretical perspectives in play. And of course, we had and experienced different possibilities and constraints of the use of the Danish competency framework. COM is a quite broad lens, and we needed fine-grained analytical tools for understanding the situations deeply when we went into the classroom. And the case of tool-based mathematical communication is an example of such. But COM provides possibilities to points for directions in the research, but also to put things into practice. So when we discuss our results, the Danish competency framework appears for us to be relevant to use. So finally, common for design research and networking of theories is the aim for developing theory, and also for some parts of the networking strategies also to develop practice. So we found of different potentials of networking of theories within design research, and that is, it's applicable when we have unrelated theoretical perspectives. We want to strengthen theoretical development in design research by refining and connecting theoretical perspectives with additional steps of theorizing. Coordinating, combining, and integrating locally appears to fit the aims of design research as well, having the purposes of both developing theory and practice. We have triangulation, and then an exploration of these basic assumptions, background theories of each theoretical perspective in play. And then finally, we also found that design research also supports networking of theories by providing possibilities to explore different theoretical perspectives, and for testing these networked theoretical work while being in practice. Yeah, thank you. Then it's Uffe again.
Yes. So it's my task to wrap up everything. One other thing I would like to mention that came out of this is the notion of mathematical digital competency, which we have worked with during the process of this project and also in other projects that I'll mention briefly in a minute. It sort of takes its departure point in this quote here: the heavy reliance on digital tools in the teaching and learning of mathematics today often called for a simultaneous or maybe almost simultaneous activation of both mathematical and digital competencies, what might be referred to as mathematical digital competency. So we, Irene and I, published a paper on this in Educational Studies back in 19. And this notion of mathematical digital competencies draws on the COMP framework, of course, and then on the instrumental approach and the theory of conceptual fields. And this is just to say that these theoretical elements seem to actually supplement each other quite well. We then brought this into another project that I had with Morten Misfeldt, where we were looking at students programming and computational thinking in combination with mathematical digital competency. And also here related to aspects of the COMP framework. So this project is also now ending. No PhD dissertations came out of this project. There were only postdocs, but 2 babies, right? So, and the international collaborators were Irene and the sadly departed Kaiser Borting. The newest thing we have in relation to this is an expansion of this MDC construct, where it's sort of related to MDC, we call it MDC for teaching. So I'll read a quote here. It appears obvious that for students to develop MDC, we need to consider teachers' MDC. But not only that, we also must consider the pedagogy necessary for teachers to employ to develop their students' MDC. This notion is what we characterize as MDC for teaching. So this paper is very recently published in ZDM. It becomes quite theoretical because we wanted, of course, to rely on the MDC construct, which is already relying on other theoretical constructs, and we wanted to expand this, and we had a lot of problems convincing the reviewers and the editors to actually go with this. But yes, we think it works. So here we draw on didactical pedagogical competencies, the 6 that we talked about very briefly in the beginning, instrumental orchestration, since this is related to teaching, and the documental approach to didactics. And of course, PCT, and we're using an empirical case that Raimundo and Andreas provided us with from the PCT project. In relation to the current project, I mean, now we are counting what did we do, and we have to write a final report. But one of the things that we are working on currently, as a spin-off on this, the last slides that Cecilie presented, is a paper addressing the link between design-based research and networking of theories from an implementation research point of view. And we hope to publish this in the journal, Implementation Replication Studies in Mathematics Education. We will have a firm discussion with the editor-in-chief about this, of course. And now the most important slide. Are you happy, Morten? Wonderful. Thank you very much.
Okay, thank you to Uffe and Cecilie for this very interesting talk. So I think we now have time for some questions or comments that so please, if you have any clarifying questions.
No questions. Then it's coffee break, right?
Thank you for very intriguing and interesting presentation and multi-layered. Where is this MDC, the Mathematical Digital Competence, located in your nice flower of competency framework?
No. It's
a separate thing. So you need to do another integration project to integrate that.
No, I don't know if we need to do another integration. It draws on the competency framework, right?
Okay.
But it's a suggestion for something else to look at when using digital tools. Another approach.
So what about TPAC and MDC for teaching? Is there connection?
We have looked at this actually previously in some old papers, trying to network this also in relation to this MDC-T, if you want to use all these abbreviations. But we ended up going with these other approaches, instrumental orchestration and the documental approach to didactics. They seem to do the job better for us. But you could have gone with other constructs as well, and we did try it out. And it's published in a proceedings paper somewhere, yes.
Okay, thank you.
Quick question. So you were considering some of these competencies separately, it seemed, in these projects. So different. So can you say something about the limitations, consequences of taking such an approach?
Is that me?
I think it's you, yes.
Of course, when you use digital tools, we are not only focusing on, for instance, the communication competency, but also the aids and tool competency. I would say that it's very difficult within one project to focus on all 8 competencies because they cross with so many different research areas at the same time. So you would need to be able to, some parts of the project, focus on explicit some parts of the competencies. But there's of course overlaps between these competencies. Also the communication competency and the representation competency are quite overlapping actually, because of the importance of representations in communication and the use of these representations while communicating. So yeah, sometimes we actually discuss that some competencies may be grounds for other competencies, which is maybe not, I don't know. Thomas is sitting down here. He may also help. But yeah, I don't think that it's possible to focus on all 8 at the same time. So you need to somehow make the situation more simple and then focus at least on 1, maybe 2 within a single situation.
Thank you very much for an interesting talk. You started off by bringing us into the classroom in a quite ordinary, I would say, type of situation that I've seen many times. And then you went off on a very theoretical track. So theorizing about this is also important, I'm quite sure of that. But I was thinking, do you have any thoughts of how you are going to bring these insights that you've made back into the classroom to this teacher, these students, and how to help them develop their mathematical competence, communication competency and representation competency?
Yes, so there's different perspectives on this, but I think that one part could be these design principles, because they include, which is of course a big part of design research, yes, so these design principles actually provide perspectives on how to design the different teaching situations in which students may exercise communication competency, and what kind of phases you could have within the teaching while using digital tools. This is also why I was so focused on our work on the design principles for the representation competency, because it kind of is a nice way to relate practice and theory. And it may very quickly, yes, be very theoretical. So the problem for the communication competency was that it's not, I think there exists one paper in research before I started looking at it, as it's described in Comp. So I didn't have much to lean on. And I needed some lens to understand the situation. I was also started actually to wonder if I should focus on developing the communication competency, but I thought that I needed to go a step back to just figure out how to even exercise communication competency in class. So I needed to make the situation simpler at first. But yeah, I could have gone other directions, focusing on written exams or something. Very focused on communication. Yes?
I just want to comment on that, because I know there are a lot of people sitting here that are doing or will be doing research in the similar areas, and maybe I just want to say that this is the next step we need to take, taking your design principles and actually bringing them back into the classroom and describing what kind of, or investigating what kind of concrete tasks and ways of teaching that can come out of it.
Yes. That's true.
I don't know, that probably leads a little bit further, but you have that. First, thank you. I'm sorry. I was very interested in what you do, because I also do some research on that. And you have those situations where children use or act with the representation modes connected. And you usually see children in lower ages who don't use that connection. And we, from a theoretical perspective, we really think that could be something. But in the lower ages, we remarked that we really have to kind of lead the children, and we need the teachers. Did you also had such situation where the representations kind of meant nothing to the students, and they were like, I don't know what's happening here? Kind of lost?
Yes, I guess. Well, the representations in these dynamic geometry environments, of course, when we see the static template, it's less complex, but this dynamic situation also even further complicates the situation for the students. And one part of the literature review and our recommendations, which we actually also brought into the work on refining the principles, is that students, we need to reduce the situation and then gradually introduce the new representations within the tool. And this linking between the representations does not necessarily occur automatically as we think, because they hold potentials, sure, but they also bring a lot of constraints and difficulties. We also did a lot of work on using Duval's reflections of how the complexity is increased using these dynamic representations, because when we use the dynamic geometry environment, suddenly we are capable of dragging and tracing and zooming and manipulating representations almost as if they are real objects. And this is quite far away from, and that may lead to that student could potentially, it could be difficult to distinguish between object and representation for the students. So there's a lot of problems. Thanks. In that regard.
So thank you for all of your questions, and you have a chance to meet these two persons at 11:15 in the session called Meet the Plenary. So please come and ask more questions. So you should also have a small gift, a very special Danish one.
Thank you.
Thank you.
So thank you again, and please.